These are called the addition rules for probability. The addition rules for probability are typically or questions. For example, what's the probability of doing A or B? What's the probability of drawing a red card or a black card? So whenever it's an or question, it tends to be one of the addition rules. So the first property we need to talk about as far as addition rules for probability is mutually exclusive. Two events are mutually exclusive if they cannot happen at the same time. Mutually means together, exclusive means nothing else. So they can't happen together. Two events are mutually exclusive if they cannot happen at the same time. If two events are mutually exclusive, the probability of either A or B occurring is the sum of their probabilities. So you can see there the probability of A or B is equal to the probability of A plus the probability of B. That's why this is called the addition rules, because whenever you have an or, you tend to add. So our first example up top, what is the probability of rolling a 2 or rolling a 5? So the probability of rolling a 2 or rolling a 5 is the same as the probability of rolling a 2 plus the probability of rolling a 5. So we can really just break this down into two smaller questions and then add our results together. So first we think about just a normal six-sided die. What would be the probability of rolling a 2? Well, if the die has 1, 2, 3, 4, 5, 6, then there's just 1, 2 out of 6 possibilities. So it would be a 1/6 possibility. And then the probability of rolling a 5 would be the same. There's a 1/6 probability of rolling a 5 in a normal six-sided die. So the probability of rolling a 2 or a 5 is the same as the probability of rolling a 2 plus the probability of rolling a 5, which would be 2/6, or reduced, it would be 1/3. Next example. If you have 2 red balls, 3 blue, 9 yellow, and 10 green, what is the probability of choosing a red or a blue ball at random? So same as before, the probability of a red or a blue is the same as the probability of a red plus the probability of a blue. So let's see, we have 2 reds, 3 blues, 9 yellows, and 10 greens. That would tell us that in total we have 24 balls. Well, there are only 2 reds, so the probability of a red ball would be 2 out of 24. Plus, the probability of a blue ball would be 3 out of 24. So if we add those together, the probability of getting a red or a blue would be 5 out of 24. So first we talked about mutually exclusive, meaning two events cannot happen at the same time. Looking back at the previous examples, you can't roll a 2 and a 5 on the same die at the same time. If you draw one ball, you can't get a red and a blue at the same time. But there are events that are mutually inclusive. These are events that can happen at the same time. And if two events are mutually inclusive, then the probability that either A or B occurs is the sum of their probabilities decreased by the probability of both occurring at the same time. So here's the formula for that. The probability of A or B, if they're mutually inclusive, meaning they can happen at the same time, is equal to the probability of A plus the probability of B minus the probability of A and B. So if you've worked with Venn diagrams before, this is one way to help explain this rule. Events that are mutually exclusive have no overlap whatsoever. They can't happen at the same time. So if the probability of this is 1/3 and the probability of this is 1/3, then added together it's 2/3. But if two events can happen at the same time, and let's say this whole circle, the whole circle is 1/3, and the whole circle here is 1/3, but this little piece is 1/6 where they overlap, then what happens when we add 1/3 plus 1/3 is we end up adding this piece twice because it's inside both circles. And we don't want to add the same things twice. We don't need to count them twice. So to correct for that, we have to subtract 1/6 from our total. So we would do 1/3 minus plus 1/3 minus 1/6. So that would be 2/3 minus 1/6 would be, I think, 1/2. So let's think about the Avengers for a second. Forgive me if you're not very familiar with these, but I hope this example will land for most of you. If we just talk about these 6 Avengers, superheroes, Thor, Iron Man, the Hulk, Captain America, Hawkeye, and Black Widow. Let's say we're choosing one of these Avengers at random, and we want to know the probability of choosing someone with 2 names or one who actually has superpowers. Okay, well, let's list all the ones that have 2 names. So Iron Man has 2 names, or 2-word names, I guess is what I'm getting at. Captain America, his name has 2 words, and then the Black Widow. Now let's list the people who actually have superpowers. Okay, well, Thor has superhuman strength, among other things. Iron Man does not. He's just a very rich guy with a highly technological suit. The Hulk, I would be willing to say, has superpowers. Turns into a giant green monster that can do anything. Captain America has superpowers. But Hawkeye is just a normal guy who happens to be really good with a bow and arrow. And Black Widow is just a really good super spy who can fight. So she also doesn't have any superpowers. So you see that we have an overlap here. If we just add these together, we would think that there was a 3 out of a 6 chance plus a 3 out of a 6 chance, giving us a 6 out of 6 chance. But that's clearly not the case, because that would imply that 2 names or superpowers would be all of them. But it's not, because we've counted Captain America twice. So there's the overlap. The person who has 2 words in their name and has superpowers is Captain America. So we have to do 3/6 plus 3/6 minus 1/6, which gives us 5/6. And that makes sense because there's only 1 out of the 6 who doesn't either have a 2-word name or superpowers, and that's Hawkeye. All the others, if we randomly picked them, would either be someone with 2 names or who has superpowers. So what is the probability of choosing a queen or a red card from a deck of cards? So we have to think, is this mutually exclusive or mutually inclusive? Well, this is mutually inclusive because it is possible to be a queen that's also a red card. There are 2 red queens in the deck. So we take the probability of a queen plus the probability of a red card, and we need to subtract the probability of a red queen, because that would be where they overlap. So the probability of a queen, well, that's 4 out of 52. There's 4 queens out of the 52 card deck. Red, that's half of them, so that's 26 out of 52. And then there are just 2 red queens, so we subtract 2 out of 52. So 4 plus 26 is 30, minus 2 is 28. So you get 28 over 52, which you can reduce to 7 over 13. So the probability of randomly drawing 1 card from a deck and it being either a queen or a red card is 7 out of 13, or 28 out of 52. Again, the reason we have to do the subtraction is because there's overlap. We've counted all 4 queens here, and we've counted all the red cards here. But the Queen of Diamonds and the Queen of Hearts are in both of those categories, so we've counted them twice. They were counted when we counted the 4 queens, and they were counted when we counted all the red cards, so we had to subtract them once, so we were only counting them once. Let's say that the probability of passing the road test is 5 out of 6 when you're getting your license, and the probability of passing the written test is 9 out of 10. The probability of passing both is 4/5. So what's the probability of passing either the road test or the written test? So these are obviously mutually inclusive. You can do the both at the same time. In fact, hopefully you will, or you did. But you can pass the written and pass the road test when you go. So these are mutually inclusive. So first we figure out the probability of them individually. The probability of the road test is 5 out of 6, plus the probability of the written test is 9 out of 10. But we have to subtract the probability of them happening together. So minus 4/5. I'm going to let the calculator help me out on this one. So 5 out of 6 plus 9 out of 10 minus 4 out of 5. So the probability of passing one or the other is 14 out of 15.